So good morning. We are here to answer questions on worksheets. And there was a question on the 4.7 worksheet. When we're doing the empirical curve, let me share my screen here. The question was asked, if when we do this curve, will the area always be the same? So when we do this, right, with our percentages, will this always be 34% and this always be 34% and so on? Yes, that is true. So the percentages are always the same. The only thing that change are your data values that go down here. So your variable outcomes. So this is always going to be your mean. It's always in the center. And then these are always going to be your standard deviation markers with your data. So using your mean and your standard deviation, this is going to be 1 standard deviation, 2 standard deviations bigger than your mean. And this will be 1 standard deviation and 2 standard deviations smaller than your mean. So the percentages are going to be copied just like they are in the book, in the lesson that we went through. And then your data values are going to fall here. And then looking at your data values, that's going to tell you something about the percentages between your data values. But the question was asked, what if we had to find a different area? So in this course, we are only going to know these areas. 34%, 34%, 13.5, the 2.3 and the 0.15. All of these things. All these percents are all that we're going to know in this class. Now, what if I wanted to find what standard deviation would represent 22% to the right? So it's somewhere about a half of a standard deviation. I can't find those percents in this class. If you take my stats class, we learn that in that class. But these are only the typical empirical rule percentages that we learn in this class. Now the end 4.7, right? The end of 4.7, we learned how to find a z-score, which is finding your particular number of standard deviations that you are above or below the mean, but we don't do anything with other percentages or area, if that answers that question. So the question was asked, if we continued going further, say 3 standard deviations below and above the mean, eventually, if we keep going, we'll get to below 0 on our outcomes, and it'll look like we're going to go negative on the percentages and we're going to go bigger than 100% on the percentages. We can never go that. So what happens is this becomes very, very close. It gets very, very close to 0 out here and gets very, very close to 0 out here. But it never goes below a 0 percentage and it never goes above 100%. So 100% of your data is under here, but it never can go -% or more than 100%. And that's why I mentioned in the lesson, might be good to watch the lesson twice, just on this ending part of 4.7, just because it gets a little bit tricky. Is where I say whenever you're outside of 2 standard deviations, above or beyond, is when we're considered unusual. So it becomes very, very odd when values fall outside in this space. Very, very odd and unlikely. Okay, now we clarified the question of, can my percents be higher than 100 or lower than 0? So because I thought the question was being asked about percentage under the curve, but on the worksheet, we're talking about percentage on a test. And so when I'm filling out my scores down here, because this time my variable name is called the score on the fall 2018, which was exam 3, right? And so we're going to fill out the curve because you are going to have percents on the exam that were bigger than 100 over here and smaller than 0 over here. But a student could never get those, right? And so that's why they become unreachable as far as that goes. But I want you to fill out the curve so that you can see that that would actually never happen. Is that a little more clear, Stephen and Shelby, on your question?
Yeah.
Yeah, thank you.
Okay, you're welcome. So there were some questions regarding the Unit 4 project in the first task. So, and the second task. So task 1 is all about finding a sample. So I want you to take those Jackson College employee salary data, and you're going to find your own sample of 25 of them. So you're only using 25 data points, and you need to explain how you got your sample. That's question number 1. And then question number 3 is asking you to tell me which measure of average or measure of center do you think is best describing your sample? So we're going to go the mean, the median, the mode, or the mid-range, and why, using the way we compare those in the workbook, in the lesson. The number 5 is asking you to compare those using the measures of variation, range, standard deviation, and coefficient of variation. And remember, in the 4.6 worksheet, there were 5 classes of exam data that I gave you. And if you remember correctly, class 5 scored very high on their exam, but their standard deviation was super low. Class 6 was close as far as the average exam score was like 79%, but their standard deviation was very high. So what that tells you that class 5 had a small standard deviation, which means that those students actually scored very close to that high average of 87%, whereas class 6, their average was 79, but those students scored much more spread out. So they weren't all actually centered around the 79%. So that's what I want you to explain. Is question 3 is about the measures of center, and question 5 is about the measures of variation. Then when you go down to task 2 on the population values, on the population values on task 2, you're using all of the data that I gave you, and you're going to answer the same questions about the measure of center and the measure of variation. That's what I want you to tell me. You're going to answer those questions on 2 and 3. So 2 is asking you to give me the correct symbols for each measure of like the mean has a different symbol for sample as it does population, and the standard deviation has a different symbol for sample versus the population. So another thing that got brought up about the Unit 4 project is if you want to do complete your work in Excel, because that's where the data is, you can just save it. And to calculate the mean in Excel, you're going to use the command average and then your data reference. And then the same with, for a sample standard deviation, you're going to use this STDEV, and for a population standard deviation, you'll use STDEVP. And then you can just save that in Excel, and I have allowed for you to upload Excel documents, or Excel files, I should say, into the project slot in JetNet. And that way I can just click on it and I can see how you did your calculation for those. And then maybe next to them, just type what it is, if it's the mean or the sample standard deviation or the sample or the population standard deviation and such.